Hello and welcome to the practical implementation of linear learner algorithm in AWS SageMaker. In this video, we'll do a practical implementation of this algorithm in the notebook instance of your SageMaker. So to do this, we'll be using two services. The first one is the S3 to store the data, to make the predictions and store the output. So everything related to storage will be done through the S3 service, and all the machine learning tasks that will perform will be done in the SageMaker notebook instance. So first let me open this S3 service in a new tab, and we'll wait for it to open, and I'll open this SageMaker over here. So in this new tab of the S3, as you can see, currently I'm not having any ready-made bucket over here. So based on the code that we are going to do and the datasets that will load, everything will be stored into a new S3 bucket that will be automatically created by a script. Over here, we will first have to create one notebook instance to perform the coding task. So I'll scroll down and I'll open this notebook tab and I'll click on this notebook instances. There are currently no resources, so we have to create one new notebook instance. Just click over here, create notebook instance, and let's name this sample linear learner. Notebook instance type by default MLT3 medium. We won't be doing any changes to these three. And scroll down. Inside role, I'll click over here and we'll select create a new role, and we want that this should access any S3 bucket or the data from any S3 bucket that we have. So any S3 bucket is selected and we'll create role. It will take some time to load and it says success, you have created an IAM role. So this is it. Now we'll scroll down and we won't be making any changes to all this, and click on create notebook instance. So as you can see, sample linear learner, the name of our notebook instance type MLT3 medium, and this is the creation time that we have created right now. Still we don't have anything in the S3. When we start the coding part, then automatically the bucket will be created and everything will be loaded into that. Status, it currently shows pending, but after waiting for a few minutes this will be there in service, and once this notebook instance is ready and it's there in service, then we can open the Jupyter notebook section and perform the coding example. So here I'll pause this video and we'll continue when this notebook instance is in service. Now you can see over here the status shows in service, and what we have to do is from actions we'll click on open Jupyter. So this will open our Jupyter notebook instance on the AWS cloud. We are redirecting to your notebook instance for sample linear learner. This will take some time to load. Once this Jupyter notebook is ready, then we have to upload the Jupyter notebook that you have in your resources section. I have already created mine and I'll show you how to upload and perform the task. As you can see, now our Jupyter notebook is ready. We have to click on this upload, and I'll upload this linear learner example one. This Jupyter notebook, I'll share it in your resources section, and I'll have to click on this upload. This will be uploaded over here, and we'll open this notebook in a new tab. As you can see, now the Jupyter notebook is completely loaded, and we can now discuss the problem statement and perform the coding tasks. For this illustration, we have taken an example for breast cancer prediction using the very famous UCI's breast cancer diagnostic dataset. The purpose here is to use this dataset to build a predictive model of whether a breast mass image indicates benign or malignant tumor. Let us start by specifying that the SageMaker role ARN used to give learning and hosting access to your data. Now this snippet below will use the same role used by your SageMaker notebook instance. If you're using something else, otherwise you have to specify a full ARN of a role, with SageMaker full access policy attached. The S3 bucket that you want to use for training and storing the model objects is over here. As of now, it is not created because we haven't executed the cells from our Jupyter notebook. So still, if you refresh, you won't see any bucket created. If I just run this first cell, here we have imported the required libraries OS, Boto3, RE, SageMaker. Now Boto3 is the Python library that you use to connect your Python code with different AWS services. Over here we are getting one error. So to solve this, we need to first install SageMaker-u. So first let us run this pip install SageMaker command. Once this is successfully installed, then again we'll try to run this cell and see if we are still getting the same error or not. We'll wait for it to execute. Over here, as you can see, you have a star mark, so that means the cell is still executing something. Now it is completed. So let me run this one more time. Now this cell is also successfully running, so we are not getting an error. So in case if you're getting error on your practical implementation, try to first run the cell and then run this first one. Let me scroll down. Now we will import the Python libraries that we need. So pandas and numpy to perform the basic data science operations, like we'll have a CSV file to work with all that. We will need pandas and numpy. Matplotlib to make some plots, and IO, time, JSONs, and SageMaker libraries to perform the ML tasks on SageMaker. So let me run this cell. Again, we are having a star mark, so it is still executing. Yeah, it is successfully executed. Let's download the data and we'll save it in the local folder with the name of data.csv, and we'll take the look at it. So this will connect it to the S3, the Boto3.client. As I told, Boto3 is the library that we use to access different AWS services from our Python code, and the client is S3. File name, this is the CSV file that we'll be working with, and we'll accessing it through a URL that we have, and this is how it will be stored inside the S3 bucket. And pd.readcsv, this file name will be stored inside this data frame that we created. These will be the sum of the columns, and finally we have to save it data.csv. So let me run this cell and see what do we get in the output. So over here, this is the data set that we'll be working with, and over here let me scroll down and scroll it over here. So this is the data set that we have over here. Now let me go back to our S3 section and see do we have something. So let me refresh it, and let's go to buckets, and over here as you can see we have this SageMaker US East 1 bucket that is created for us. Let me open this bucket, and as of now we won't have anything inside this. Let me scroll down. So let us understand some key observations about our dataset. So this data has 516 observations and 32 columns. The first field is ID. Second field is diagnosis, which is an indicator of actual diagnosis. M stands for malignant and B stands for benign. So let me scroll up. This is the ID column and this is the diagnosis field that we'll use, B and M. So this is a binary classification problem. There are 30 other numeric features available for predictions. Now our task is to create features and label. So firstly, as we usually follow in our machine learning lifecycle, we split the data into 80% training, 10% validation and 10% testing. Let me run this cell for that. Now we'll convert the data set to the record IO wrapped protobuf format that is used by Amazon SageMaker algorithms, and then upload this data to S3 and we'll start training the data. So let me run this cell, and we'll also convert the validation set into the format that is accepted by the Amazon SageMaker algorithms. Now we begin to specify a linear model. Amazon SageMaker linear learner actually fits many models in parallel, each within slightly different hyperparameters, and then returns the one with best fit. This functionality is automatically enabled. We can influence these parameters like number of models to increase the total number of models to run. The specified parameter will always be one of those models, but the algorithm also chooses the models with nearby parameter values in order to find a solution nearby that may be more optimal. In this case, we are going to use the maximum of 32 models. Loss, which controls how we penalize mistakes in our models estimates. For this case, let's use absolute loss as we haven't spent much time cleaning and data preparation, and the absolute loss will be little less sensitive towards outliers. And these are some regularization parameters. Regularization can prevent model overfitting by preventing our estimates from becoming too finely tuned to the training data, which can actually hurt generalizability. In this case, we'll leave these parameters as default and auto. So from SageMaker, import image URIs. So this is the linear learner and linear learner image that we are importing from SageMaker. Let me run this, and now finally we'll train the model with all these parameters and store the data in this S3 path locations that are given over here. So let me run this cell. It will take some time to run, and it says job name. It has created one job to train the model. So now the job is ready. Let's kick off the training job in SageMaker's distributed managed training using the parameters that we just created over here. So because this training is managed, we don't have to wait for our job to finish to continue. But for this case, let's use Boto's free training job completed or stop waiter, so we can ensure that the job has been started. Let me run this cell. Now it shows in progress. This will actually take quite a few, let's say 2 or 3, 4 minutes as far as I think. So I'll pause this video over here, and once we'll continue once this training part is complete. Now as you can see, this cell is successfully executed, and it shows CPU times user 104 ms, and total it took, the total wall time was 4 minutes. So this is now successfully executed. Now let me scroll down and let's move to the hosting part. So now we have trained the linear algorithm on our data. Let's set up a model which can be later hosted. So let me run this. So linear hosting container, and we'll try to host this model and use it later for our predictions. So this one URL is connected for the linear model. Once we have set up a model, we can configure what our hosting endpoints should be. Here we specify the EC2 instance type for hosting, initial number of instances, and our hosting model name. So this is a linear endpoint, and the instance type that we'll be using will be m1 ml.m4.extra large. You can also change the instance type, but as of now we'll go with this, and we'll try to run this cell. Demo linear endpoint configured, and in the S3 storage that the data and model is ready. So now that we have specified how our endpoint should be configured, we can create them. This can be done in the background, but for now let's run a loop that updates on the status of the endpoint so that we can know that we are ready to use. So again, the execution of this cell will take some time. So till it executes or the status is creating, let's check the S3 bucket that we already have. So inside this S3 bucket, now you can see you have this SageMaker / folder, and inside this folder we have our demo breast cancer prediction, and here we have this linear model, train and validation data splits. Let me go back to the buckets, and this was the bucket that was created, and this cell is still executing. The endpoint has been done, and if we get any error, then the endpoint creation did not succeeded. We'll see this message, but I hope this runs successfully. Currently the status still shows creating, so we have to wait for a few more minutes. So the cell is now, as you can see, the execution of this cell is successful, and the wall time was 4 minutes 1 seconds, and the status is now in service. So the endpoint is in service. So let's make some predictions on this. Now that we have our hosted endpoint, we can generate statistical predictions from it. Let's predict on our test dataset to understand how accurate our model is. There are many metrics that you can use to measure the accuracy or the performance of a classification model. Some common examples include precision, recall, F1 measure, area under the ROC, AUC curve, total classification accuracy, or mean absolute error. For our example, we'll keep things simple and use total classification accuracy as our metric of choice. We'll also evaluate mean absolute error as the linear learner has been optimized using this metric, not necessarily because it is a relevant metric from an application point of view. We'll compare the performance of the linear learner against the naive benchmark prediction, which uses majority classes observed in a training dataset for prediction on the test data. Next, we'll invoke the endpoint to get some predictions. So let me run this cell and let's compare the linear learner based mean absolute error prediction errors from Bayesian prediction, which uses a majority class to predict every instance. So let me run this. So the test MAE baseline is 0.278 and MAE linear is 0.165. So let's compare the predictive accuracy using a classification threshold of 0.5 for the predicted and compare against the majority class prediction from training data set. So let me run this next cell. So prediction accuracy is almost 100% and baseline accuracy is 72.2%. Sometimes the accuracy can fluctuate between 90 to 100%. This can be a little case of overfitting, but anything above 80 to 95, 99% is a very good accuracy. Let's clean up the resources. So this will clean up all the things and I'll share this Jupyter notebook with you guys. But before that, let me also delete the S3 bucket. So because otherwise we'll be charged for this S3, and this bucket is still, it has the objects. So before deleting that, we have to empty this bucket. So let's type permanently delete and click on empty. So now let's click on exit and over here let me delete this. So we'll paste the name of the bucket created for us over here and it will delete this bucket. Yeah, so now everything is deleted over here. Let me close this, close this, close this, and finally we have to stop the service. So I'll stop this and the status will change to stopping. Once the service is stopped, then we have to delete this notebook instance. So I hope you are clear with the entire practical demonstration that we did in this video. Thank you for watching. Now let's move to the next one.